We'll look at one more topic here, turning points. What is a turning point? So a turning point is the point where the graph changes from uh, increasing to decreasing and vice versa. So every time it changes, um, we call that a turning point. So for example, if I have a graph that looks like this, then I'm going to just start counting the number of times I'm changing directions so I'm going increasing, then decreasing, that's two, um, increasing again, then decreasing and increasing. I got 1, 2, 3, 4. So right now what I have is for this question, 4 turning points. So that's really what a turning point is, 4 turning points. So it's when I'm going from increasing to decreasing and vice versa. So notice an nth degree polynomial has at most n minus 1 turning points. So what does that mean? If I have a 8th degree polynomial has at most 7 turning points, meaning it could have less. So if I turn this around, for example, what is the smallest degree of this polynomial? What is the smallest degree? This polynomial could possibly have. I mean, it could be higher, but it has to be at least that. Sorry, I'm running out of room. And since this has 4 turning points, the smallest this could be is 5th degree. And there's other telltale signs that will help me, but that's one thing that a turning points can tell you, because there's 4 turning points. This has to be at least 5th degree. So in other words, a 5th degree polynomial has at most 4 turning points. Okay, so here's another example. How many turning points does f of x squared minus 5 have? So now I have to recognize, what is this? I'm hoping now recognizing that this is just a basic quadratic x squared, but transformed. How? Hey, look, I'm vertically stretching by 4, and it's a downward shift by 5. But is that really important? Not really for this, because I recognize it as quadratic. So even though it's looks like this, something like that. Again, it's been moved down, shifted 5 units. I can see that it has 1 turning point. Okay, so this one has 1 turning point, it's quadratic. So often people ask me, well, how do you remember this? I just use the quadratic as my example. So if I'm going, gosh, how many does a blah degree polynomial, how many turning points that has at most? I just go to this one. So notice the 2nd degree polynomial has 1 turning point. So that helps me remember this statement. But again, I can't emphasize enough, this is at most. So for example, how many turning points does this one have? And it's a cubic. So notice again, the basic function g of x is x cubed. And remember what this one looks like. It's one of the ones that you're supposed to remember. This one looks like this. And what is that? What does this one do? Well, this one is the same, but it's been vertically stretched and flipped across the x-axis. So when I graph this, this is going to be tighter, but flipped the other direction. So now, how many, this is a third degree polynomial. But for this third degree polynomial, how many turning points does this have? And the answer is, well, notice it's decreasing, 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 decreasing. This has 0 turning points. In other words, it's been decreasing and it continues to decrease. It doesn't go from increasing to decreasing. Okay, so that's what we mean that nth-degree polynomial has at most n minus 1 turning points, means it could have less, and in this case, it does have less. It has 0 turning points. Okay, what is the maximum number of turning points 5x, negative 5x cubed minus 3x can have? So again, it's not telling you how many, what is it, what is the maximum number of turning points that this can have? Okay, and I'm not asking you to tell me how many it has, just at most, how many does it have? So because I look at degree, this is a 5th degree polynomial. It has at most 4 turning points. So that's it. What is the maximum it can have? It can have at most 4 turning points. Why? Because it's the 5th degree, and it says again that an nth degree polynomial has at most n minus 1 turning point. So again, 1 less than the degree. Suppose now I want to sketch this. Let's sketch the polynomial, this one right here. All right, if I want to sketch this, then let's see what I can do here. I'm going to go through this process of finding, for example, the zeros, but to find the zeros, it would be better if I were to have this factored. So I see that there's a common factor of x squared, so I'm going to factor that out. That gives me 5x minus 3 here. Great. And to find the zeros, so right now I'm going to, in fact, it's a really good idea as you're doing your work to label what you're trying to do, so that way you don't get confused. So I'm going to find the zeros right now of this polynomial. And immediately I said, okay, the product of this, we want this now to be equal to 0, and the only way this product equals, so first I think I'm just factor. Now I'm going to set this equal to 0 to figure out the zeros, and I got x squared is equal to 0, or negative 5x minus 3 is equal to 0. So here, the only way this product can be equal to 0 is if x equals 0, visually inspecting it, or taking the square root of both sides. Here, it's a linear, so I'm going to just add 3 to both sides, divide by 5, and I get negative 3/5. So this has 2 zeros. Okay. So I'm going to sketch my 2 zeros here, 1 at 0, and negative 3/5. That is less than 1. So 1, 1. And so imagine this dividing this to 5 parts, 1, 2, 3, 4, 3/5. So it's just about right there. So I have these 2 zeros very close to each other. Okay. So the next thing I do is I look at the local behavior. Local behavior says that right at this 0, which is the negative 3/5, it should look like a straight line. However, at this one, this 0 right here, notice it is a multiplicity 2. So it should look like a little parabola right at that point. Okay. So now the question becomes, okay, I want to sketch this polynomial. So now I'm also looking at the leading coefficient, and I notice the end behavior. Something to keep in mind, the end behavior is governed by negative, the highest degree, which is this one. So if that's the case, what does this do for me? Well, I know that it's that cubic, and because the negative is upside down. So really the basic look of this at the endpoints is this. So it goes up and then goes down. So now, having said that, without really worrying too much about how I'm going to approach this, I realized that here's my endings. And the endings of this sketch I'm about to do have to match this. Okay, so that means here I'm coming from negative infinity. And I begin, so I have to, looking at my end behavior, it's going down. And I have to cross that point because that's a zero, have to, and it's a straight line, so I have to go right through it. And there it is, I went through it. But immediately I have to turn around because I have to hit this point, another zero. So I can't just keep going down, I have to trace back up. But when I hit this one, I said the behavior of this is multiplicity 2. So I have the following zeros. So let me actually organize those. The zeros and their multiplicity. So 1 0 is negative 3/5, and this is multiplicity 1. So it looks like a straight line right around that zero. The other one's 0, but this is a multiplicity 2, so it looks quadratic. So in that case, as I'm approaching this point, hit it, it's got to bounce this. So it's got to hit to go through this one, bounce. But after that, there's no more zeros. There's nothing going on. And I look at my end behavior and I see it continuously go down. So it just looks something like that. So again, in order to sketch this, I had to determine the zeros, find the multiplicities, look at the end behavior, and also look at the transformations to help me out, sketch what the end behavior should look like, and then that helps me determine how to start this graph. Also notice one last thing, that to do any sketch, you have to start at the end, one of the ends. It doesn't really matter which. Since I read from left to right, I decided to start here. So then when I'm starting to do my sketch, I look at this end behavior and start up here because I realize that's what it's got to look like. So, and then after that, I'll let the zeros and their multiplicity guide me. And then at the ending, I look at the ending once I'm done through with the zeros and it goes down. And that's the end of it. That's how you do a sketch.